features on object-oriented try to let us avoid the redundancy. So we save the time and the effort. Okay? So those are the objectives we're going to cover today. We'll talk about the relationships on the classes, the inheritance. We will talk specifically about when you're having the overriding and overloading for method specific type or specific features you can use on methods. And we also is going to talk about the object class, which is Java built-in class. And we will talk about the polymorphisms and dynamic binding as well. So, relationships, if you have classes, and this is the normal things we have on Java. Either you have a built-in classes, such as a string, an integer, an array list, for example, an object, all those are built-in Java classes. And sometimes you build your own classes. So at the end, you can imagine your program would have, like for now, maybe 4 to 5 classes. In a real life, it's maybe more than in a tens or so on. Okay, so when you build those classes, they're not live on your program and isolated from others. There is some relationships between them. The first type of relationships has a relationships, and the other type is relationships. The has relationships, the composition or aggregations, we already saw parts of it before, or something look like it before. Inheritance is what we're going to see today. So what's the aggregation? So we said the first type is the aggregation with compositions, right? Which is the has. So what is the aggregation model? Aggregation, when you're having a whole and a parts relationships between two classes. Okay, can you think about an example? So, for example, we can have a product, and here's a part. For example, if you have the courses, car classes, okay, although you start to mixed between the classes object and classes. The examples we had before, we have a car class, and then we have different objects with a different type, but they still are object, they are not class. In this lecture, we have a class and a class. So for example, if you have a class about university courses, so you have M251, you have M105, you have whatever. So you have the university classes. And then a part is one of the classes. For example, M125. So it's a part of it. This is an aggregation class. So if you delete the whole class, an aggregation, which has the information of the course, for example. And in this part of aggregating, is the party class will remain or okay, so let me check about meeting setting. Just give me a second. Unmute them. Okay. Sorry, because I don't hear your friend sound here. Okay, sure. I'll repeat it again. So here you have two classes. The first class is the whole class, which is the product. And the other part and the other class is the part class. The point is when you delete the product class, the whole class, you will still have this part class there. Okay? So if this is, I'll change the example, which is related somehow. So if I have, this is the course 251. And let's assume this is going to be students. So we having many students are registered on 251, and the courses has many students registered on it. So let's assume if I delete 251, do we need to delete the students? No. Because this student is may related to or may connected to another course as well. So this is the aggregation relationships, okay? So even if you delete the product, the parts get to be remain. The other part, or the other example of the aggregation is the compositions. It's similar to aggregation, but it's stronger. What do we mean about stronger? Because if you delete the composing or the aggregating, this is the aggregating here, the whole, the complete, the total, okay, the object. If you deleted, all of the aggregated composite is going to be related. For example, if you are designing a website and you have a window, that Windows object has a scroll bar and it has a buttons. There is no meaning for us to keep scroll bar down, scroll bar or buttons if we delete the window. So that means whenever you delete a window, you have to delete scroll bar and a bottom class as well. And you see here how we present the relationships. Here it's fold. The shapes is fold. The other things that each scroll bar has one window. That's mean whenever this is related, there is no meaning for this class to live, to stay, because the relationships is one in this side, in the window. Okay? So in the compositions, in the aggregations, you see the shapes, it is empty. And we have relationships is many. So the part has many products here. So that means you cannot delete the part because it is also maybe related to other products and so on. Okay? Okay, Asil. So, aggregation, let me repeat this one more time. Aggregation, if you're having a class, it's like product. So if you're having students, as I just said before, and you have courses, which is one of them is going to be M251. The students may register on another classes as well. Good. So if we delete the product, there is still, you cannot delete the student because the student is still registered on university, even if he's not registering in this class, okay? So you need to keep a part. However, in the next example, when you have a window and scroll down in the bottoms, whenever you create a delete window, you have to delete scroll bar and the bottom as well, because the relationships is one here and it's composite relationships. So the bottoms is strongly related to the windows. It has only one windows, okay? So let's see this example. This may make it a little clear, more clear, sorry, about compositions and aggregation. So let's assume we're having a student here. Student class is the main class. This is what we are talking about. So imagine yourself, you are the one who's going to be on the student class. So you are the object later. So your colleague at the beginning, when you confused between we having the class car, so students like Fatima or Ali is going to be object of this class. But let's assume we're having another class. So we'll address and a name here going to be another class. So let's try to focus on student class. Okay. So on the student class, you see we call name and name. We're not care about a name, the second one, because you can call it name, you can call it name 1, 2, 3, 4, you can call it only n. What we care about is a name because it's the type. You remember, if we would like to create an object from circle type, we put circle. If it's an integer, we will call it integer. So circle is the built-in, the user-defined class. An integer is the built-in class from Java. So first you need to define what is the type. So type is name. Where is the class name? Here is the class name. You can imagine inside the name you have, for example, first name, string, first name, string, last name. Good? Then we have another variables. It's called addresses. We can call it address 1, 2, 3. What's important is the type. Its type is address. Where is the address class? Here is the address class. An address class can have, for example, street name, street number, a city, a country. So it can have, for example, 1, 2, 3, 4, 5 lines of informations. Here we said a first name and a last name. Good? So let's assume you have a student. There is a new student who's registering in this university, in AIO, okay? Then the student, each student has a name. So each student has a name. You cannot have a student without a name, right? And each each name has one student related to it, and each student has one name. So far, so good. This relationships, because it's one here in the student's part, that means this is a composition. What does that mean? If you delete a student, if the student is not anymore registered on the OOU, that means we don't need a name. Why we need a name? It's not related to anything. If the student is not anymore registered on, yes, it's one-on-one relationships. But the point is, in this part, the one is close to the student. So if we don't have anymore, the student is not registered on Arab Open University anymore. So that means we don't need a name because it's meaningless, right? So this is the composition. This is an example of composition. Is this clear? So let's go now to the address. Let's assume we're having an address. And in this example, they assume the same building can have 1, 2, 3 students. So if you're having 3 siblings register in Arab Open University, okay, so that means if one of the students just graduated, for example, that means we still need the address because we still have 2 more students who's registered on the university. You can think about it, for example, if there is a student building. So that it's not going to be 1 to 3. It could be 1 to 100. So it's going to be 1 to too many. So that address is important. So even if one student is deleted, so this is the aggregation. So even if one student is deleted, the aggregation, the part, which is the address, gonna to be remain. However, in the first example, if the student is graduated, for example, the name is supposed to be deleted as well. Okay? I hope this is help you understand the example. Whoever asking me before, I believe maybe you would. Okay? Clear? Okay. Aggregation, oral compositions. In some books, they just using them they're using aggregation and composition similarly, even if they're different, because they're doing the same things, but the composition is more strong than an aggregation. So now we will move to an important concept on object-oriented. It is going to be very useful later, and you're going to use it absolutely during creating any program in the future, hopefully. So inheritance is an object-oriented feature. It's a law class to inherit behavior and data. So you need to remember, it's inherit what? Not only data, not only methods, inherit methods and data. So راح يورث inherits, it's الوراثة بين class والclass الثاني. So it is going to inherit the methods and data. So with the use of inheritance information, manageable in hierarchical order. So sometimes you can have one parent class, and then you have another child, and that child have a child. So you need to think about the hierarchical relationships between a parent and a child classes. And this is what they are calling here. Sometimes they call subclasses. It could call subclass, it could call driven class or child class. Most commonly used as a subclass or child class. So a subclass is the class that inherits the properties from others. So it's going to inherit. The child is going to inherit from a parent. Can have an addition methods and data in addition to the inherited ones. So who's going to have more features and more data? Subclasses or superclasses? Who's going to have additions, more methods and data? Okay, you think it's super, but it's not the super, it's the sub. Why? So let's assume, so you're having, this is A, and it has the data and it has the methods, and then you have B. We will see more example later, okay, if you don't get it, but remember this point so you don't forget it. So everything's in A except the private things. B can see it and use it. In addition to its own data and methods. يعني البارنت الأب عنده بعض المعلومات الداتا والmethods. البي اللي هو child going to inherit all these data and method plus راح يكون له الداتا والmethod الخاصة فيه. So that means it has an additions, methods and data in addition to the inherited one. Okay? So the inherited one, which is the parent here, inherits known as a superclasses. The superclasses hold the common data. So for example, if we think about a circle as a shapes, the parent class will be shapes. So it's just have the common features. However, for example, in a circle class, you have to have a radius because the other shapes doesn't have a radius. ما عندها نصف قطر. فهنا a child class, which is a circle, has more data than a parent class. So let's see here. This is an interesting example. So if you're having a bank account, the bank account is the general account. Then you can have a specific type of accounts, which is like a checking account or a saving account. Okay, let's focus now on the bank account, which is the general one. So we having name of the owner, a balance, a method called deposit. It is going to get as an argument the amount $. So, and it withdraw if the customer would like to take some money. So either you put some money on the account, deposit, or you take your money, withdraw. And you need to decide how much you would like to take from your account. Good. So this is some important feature on under bank class, a bank account class. When you open a checking account, it has an additions data, an addition features, and similarly saving account. For example, in a saving account, there is data called annual interest rate. So راح ترجع لك فايدة. This annual interesting rate is not available in a general account, and it's not available for checking account. And it has some other features, a deposit method, monthly interest. And here again, we see the same methods repeated again from the parent. Okay, we will talk about this later. So all the data here and all the methods can be accessed from a saving account. So here, the data is not only annual interested accounts. The data is the owner, is the balance, plus the annual interested rate. The withdraw here, this is over riding methods. So if you would like to make it a specific implementation just for saving accounts, you create your own version of this method. We will talk about it later. Okay, so what is this? Is this the super or the subclass? Is this the parent or is the child? The bank account. Good. So it's a super class, or what we could call it also parent. What about the rest, the checking and saving accounts? Good. So they are subclasses here. Okay. So let's move. We need now to remember there is different type of classes. Either you create your own class, such as when we create a circle, a TV, students, a university, whatever you create, the class you created by your own. So you name it and you put it .java, you put your constructor and your methods, your data. So this is a user defined. Okay, the Java class library, it's already built classes. Abdullah, I don't know. No, it's not a difference between an array and an array list. It is different. You mean it's as inherited? Yes, maybe. On that, in a Java class library, the array list has some features from an array. Yes. Okay. So now in a Java class library, or in a user defined, you have a class. Let's assume you have a class A, and then you can have a child or subclass class B. You can also have more than one subclass. For example, you can have a C and a D, which is a subclasses for LB. And this is what we said is hierarchical. So C inherits B inherits A. Okay. So this figure shows Java inheritance hierarchicals, including the root of the hierarchical, which is the object class. So all the objects on Java going to be under the class object. Okay. Let me just. Okay. So this is going to be more clear. Okay. So we're having an object here on top. From an object is the built-in classes on Java. Under there is a string, number, and many other classes. It's going to be under object. For example, under name you can have big integer and so on. This is going to be a long list. But what they would like to show you in this example, that built-in, so the object, the string, the number, the big integer, they are all built-in classes on Java. The class A, class B, class C, and a D is going to be defined by a user. However, although those classes are defined by a user, you can still inherit from the built-in classes. So what we see here in the example, the user-defined class A is already inherited from the class object, which is the built-in classes on Java. Okay? The idea of inheritance, it's we said before, is going to help us reduce the redundancy, so we don't need to repeat the same information again and again. And in addition to that, it's going to help us reuse some features. So it's reusable features that it's common between subclasses. Okay. And this is going to save the effort, time, avoid redundancy, and reduce the time of testing as well. We understand, hopefully, what is the inheritance, what does it mean, but how can we use this on implementation? We use word extends. The keyword extends is going to be used to represent inheritance relationships in a Java language. So here you put public class. This is a subclass name. Let's say, for example, circle, and then extend by superclass name, for example, shapes. And inside it, you put in methods and other fields that you have. Okay. Here is the full example. Let's focus on it one by one. So this is the superclass. They call it simple geometrics objects. Okay. Simple geometrics object is the subclass. The superclass, and the subclass is circle and a rectangle. In a UML, how we represent the relationships between a parent and a child, we use this arrow. This arrow means that this class is inherited from the one on the top. So you see that the top of the arrow is going to point it to the superclass. Okay. So let's see the first class, which is the general one, a simple geometrics object. It has three data variables, the color, which is string, the field, boolean, and a data creation. This is something we didn't saw it before. When you have it defined as a type from an object built-in, from built-in classes called data. So data here is a class on Java, is going to return date, okay? Then after that, we have two constructor geometric objects without any argument, with a 0 argument, and the other one is with 2 arguments, the color as a string and the field as a boolean. We will have a set color and a get color. We have a method to test if the shapes is filled or not, and we having set field to change the shapes if it's filled, to make it if it's unfilled to fill it, or the opposite. To return gets a date of creating this object, and is gonna to return an object from class date. And toString, it is gonna to return string. toString, this method toString is not related to, or is not only created in this class. Actually, toString is a method on object class. If you remember, we said it's the main class on Java. So it has toString. But here we're going to overwrite it to implement our own. التوString موجودة هي بالكلاس الأساسية للجافا اللي هي الأوبجكت، ولكن راح نستخدمها استخدام مختلف، ولهذا راح نستخدم نفس الاسم ولكن implementation مختلفة. راح نشوفها بعد شوية الغرض منها وطريقة استخدامها. تمام؟ Then we will have the subclass circle. This is, we already explained it in detail in meeting 2. We will have a rectangle, which is similar to a circle, but it's going to have weight will high, okay? And it has some other different methods as well. I'll show you this example on NetBeans. So just give me a second. Okay. So if you remember, how many classes we had? 3. We have a parent or a superclass, which is a simple geometrics. And we have a rectangle and we have a circle. Okay? All these classes doesn't have any main methods. So that's why later we have to create a class to have a main methods, and we call it a test circle rectangle. So let's see the first class here, simple geometrics objects, is the parent. You see it has some data, the color will fill. Then we having a data, and because we using a date here, we have to import it on the main on the class that have the main methods. We will see it soon. The constructor, the 0 argument constructor, is just gonna to set a date. The 2 argument constructor gonna to set a date, a color, and is gonna to set the field as user defined fields if the user define it to be true or false. It gets the color, sets the color, was gonna to get and set the color. It is field gonna to return true if the shapes is filled and false if it's not. set الفولد it's gonna to set الفولد true or false depending on a user requirements, and then this is gonna to be get a date, and you see its type is gonna to be Java utility data. And you see here, this is toString. What do we have in this toString here? It's gonna to return a string, have created on, and is gonna to return a set data from variables, and it's gonna to say color, and it's gonna to return the color, and it's gonna to say and fold, and it's gonna to get the folds here. Okay. So this is the parent class. Then let's see the first child. This is, you already know it, but it's gonna to have one more addition method. So when we create the class, how we make it as a child of simple geometrics, we said circle extends, and then we put the name of the superclass. After that, it's going to have its own data. So it has a radius with a type double. It is going to have its own constructor. Here we have 3 constructors, one with a 0 argument, one with a 1 argument, and one with a 3 arguments. What I need you to notice here, if you remember when we talked about this keyword, when we said this data radius, we mean this radius. Okay? But you see here, we use a method called setColor and setField, and those are not inside a circle. They are not inside a circle class. So they are coming from where? And we didn't call it, like, we don't create an object or methods and we call the methods. We just use it directly. So from where setColor is coming? Yes, this mean and this class. Exactly. So a setColor with setField, they are coming from a superclass. They are inherited from simple geometrics. If we go to simple geometrics, we see here we have a setColor and we have a setField. Okay. Okay, just give me a second. Look like some from friend have trouble logged into the lecture. Just give me a second. If you remember, we saw that methods wasn't exist on the child class. However, they are on the parent. So let's see the rest of the circle. I back to the circle class now. Then we will have a get radius, set radius. We already saw those in a previous meeting. What I would like to point here to is the print circle. So you see here print circle, and then we add some text or a string, and then we call get data created. Get data created. This method also is not exist on the child class. You can see it in a simple geometrics, which is here. Okay. Let's see a rectangle. Similar to circle, we're gonna to put a child name or the subclass's name. then keyword extends, then a name of the superclass, symbol geometrics. We create its own data, which is الweight والhigh. It has own constructor, one with a 0 argument, with a 2 arguments, and with 4 arguments. And again, you can see it's used the superclass methods directly. Set color with set fields, and we don't use the get date here. Okay, so let's see how we can test this. We create a class called test circle rectangle .java, which has a main method. So first, we create an object from type circle, and we call it circle. And we send an argument as 1. So what's 1 represents here? If you remember the constructor of circle, so I call the 1 argument constructor, and I send 1. So what's 1 represents here? 1 is going to go to the object or to the class circle, and is going to represent what? Can you hear me? Yes, Asil, 1. It represents what? Radius. Thank you. So 1 is the radius. So I would like you to imagine with me. I'll just comment those, and we'll focus just on a circle. So I create object called circle, and I call methods called toString. So the class circle doesn't have a class method called toString. So from where we going to bring it toString methods? From a parent. Yes, it's going to inherit it from a parent, from superclasses, symbol geometrics. Okay? And then again, get color is not a method from a circle. So it's going to be inherited from super again. Then we will call get radius. This is the class circle class method, and it gets area and it gets diametric. Okay. So let's see the output of this. So if you remember toString methods inside superclass, symbol geometrics, it is going to have a circle created. Then we have a value to bring this from a system, a data from java.utilities data, a date, sorry. So it's going to bring a date from Java utility date, and then we have a color white, and then we have a fold false. Why we have a fold false here? So if you remember on a circle, we already defined it. We already defined the circle. We don't define a color. On the symbol geometrics, we defined the color as a white, but we didn't define the fold. Why it is false then? Do you remember this information? When we're creating an object, that's object to try to find what's the value of color. The default one is white. Good. Then it is going to come to fold. Fold doesn't have any value. So why we have it false? Thank you, Bushra, because it's the default value. It's the default value. Why are we having it false here? Because it's the default value for Boolean, sorry. And the color is going to be white because it's written as a default on the superclass. It is going to having a radius as a 1, which is we send it as an argument on the main methods, and it's going to calculate the area and a diameter. Okay, so let's see if we having a triangle. It's going to be similar. So in the rectangle, we're going to have two arguments here. So it's going to call the constructor. We're going to call the constructor with the two arguments. What are the two arguments? Constructor on a rectangle. الهاي والweight. Okay. So first we're going to invoke two string methods from superclass. Then we're going to invoke get area. This is going to be from a rectangle class, and get perimeter from a rectangle class. Okay. So this is from this two sentence here, from circle or rectangle, both of them get a two string methods from a superclass. That's why they are similar. You see that? Both of them get a two string. They don't have their own two string. They use a two string from general, from superclass. Let's back to the two string methods and see it. What it has on it. So at the beginning, you have circle, rectangle. It's already printed on the class before you call to string, and then created on, and the color is going to be getted from here. Okay. One more thing. This point is not. We haven't reached this information yet, but I'm going to explain it here because we're going to get out of NetBeans and back to the presentation. في نقطة راح أشرحها الآن شوية سابقة راح نشوفها بعد شوية. To string, it is not a method only related to a simple geometric or any other class we created. Actually, it is coming from an object class. تمام؟ فهي methods موجودة في object class. What does that mean? If we don't define this class, if I delete this class, okay, and I run, you see here, I back to the main. I already have two string. I deleted from superclass and I back to the main and I still use it. I don't get any error. ليش ما يطلع لي error مع إني حذفتها من السوبركلاس؟ لأنها already موجودة بالobject class as a method. Okay? يعني هي حنا كتبناها بالsimple geometrics. It is going to override الميثودز اللي موجودة بالobject. However, if it's not defined في simple geometrics, we can still use it, but it is going to give us different results. Okay? So remember the result. Remember the result now. So this result coming from to string اليوزر defined to string اللي حنا عرفناها to string اللي موجودة بالسوبر كلاس. So I'll run it now. I'll execute it now. Compile the code after I delete to string defined by a user. What does that mean? That means inside the main is going to go to the original to string method. Let's see what we're going to get. Okay, you see here? We see circle, and then we get test circle, and then dot circle at, and then some numbers. Okay, you see the new results? It is just the freezing from my side. You see the new run? Okay, just give it a second. Okay, here you go. So it's shown now. Okay, so you see, we having circle at, and then the represent of the object. We will talk about it on the PowerPoint, the presentation now. Okay, so you see the new result now. Right? Anyone? Yes, no? Okay, good. So let's back to our presentation. Okay. Okay, so this is the example. This is exactly what we just saw on NetBeans. So you see, simple geometric object is the superclass here, and the green methods are inside parent or superclass simple geometric. The blue methods here are the circle, which is a sub or child methods, and also you can use a method from superclasses, which are the green ones here. Same with the rectangle class, which is the second subclass or the second child. You see the blue methods are its own methods, and the green, the ones that are inherited from superclass. And you see here, this is the example we just run. So we having a superclass constructor. It has a special case. What we already said that a data method is going to be inherited to the superclass. يعني الابن الchild راح يورث من السوبر all methods and data except the constructor. So the constructor, they are not inherited unless we invoked it implicitly later. We will see an example. But by default, or in a general case, you cannot inherit الكونستراكتور from superclass or parent. لأن هي إيش فكرة هالكونستراكتور؟ إنه هو راح ينشئ لك object من نوع الكلاس المعين. فأنت تحدد إنك تعمل creation للكلاس من الchild, so not from the parent type, unless you would like to use a specific features, so you can implicitly invoke it later. Okay. So the constructor is used to construct an instance of a class. Superclass constructor are not inherited. Okay. Only you can invoke it use a keyword super. Super is not explicitly used يعني ما راح تكون موجودة بشكل صريح، مش دائما أنتم تحتاجوا أنكم تكتبوها. But you can use it في التعريف الضمني إلى إنشاء الأوبجكت. So implicitly you can invoke a constructor. An example of it here. So if you create a class A, it's equivalent if it's the class A is the super, like you are using the super, which is mean this is the super statement. The same when you're having, it's either it's have no argument or it has one argument or more than. So you put a super, and if you have any statement, you put it at the beginning, so it's similar to it. If you would like to invoke the constructor. So you remember when we said this, okay? When we said this, we mean this class. Super now here, it's being referred to the super class. Similar, okay? When you can use it to call a superclass constructor from a subclass constructor. So if you are in a subclass and you would like to call specific methods or data from superclass, you use a super. So for example, if that method, if you have a method and you overwrite it on a subclasses, but you would like to use a superclass methods. So they having same name, like toString. If you create your own toString inside a circle, but you still at some point you would like to access a toString that's on the superclasses, symbol geometrics, you need to put super dot toString. So it's going to get information from the superclass. Okay. A subclass inherited a superclass, so it's going to have new properties and a new method, a subclass. And also it's going to have, it can have override a method from superclass. We will see what override mean now. Or soon, okay? So this is an example of using super keyword. So if you remember when I told you, this is, we see it in which class? On a circle class, if you remember. And then I told you as get a date created. In the example, when we run it on the NetBeans, you see it, we didn't use a super. But it's actually, it looks like you having a super dot. So this is one of the place where you can use a super keyword. So now we will move to another important concept, which is the overriding methods on the superclass. So you remember when we talk about a toString, okay? A subclass inherits a method from a superclass. Sometimes it's necessary for a subclass to modify the implementation of a method. So the superclass, a parent, has this method, has its own implementation, but it's not the one that you would like to use. يعني لما يكون البارنت أو السوبر كلاس عنده ميثود معينة مثل ما شفنا مثلا بالتوString، لكن التعريف لهذه الميثودز is not the one that we would like to use. For example في المثال اللي شفناه التوString البارنت اللي حقها الأساسية هي الأوبجكت كلاس. What's the object class gonna to return at and then a number. بس مش هذا هو المطلوب عندنا بالgeometrics. So that's why we created our own. So the toString mainly is coming from a root class, which is the class, the object class. But then in the symbol geometrics, we decide to create our own toString. So we use a toString. Similarly, if you would like, so we having an object, if you remember, we having an object, it's the built-in class. Then we having a simple geometrics, it has two string. Now, which one we have it, we're gonna to create two string for it is a circle, okay? So if you don't define or if you don't specify which two string, it is going to go to the one it's inside this class. So it's going to start it from this one here. There are some important information to remember about inheritance, subclasses or superclasses. If you have an instance methods, so if you're having any methods, these methods can be overridden only if it's accessible. What does that mean? Sometimes you create a method inside a superclass, for example, but it cannot be accessed by a child. If I have, for example, a modifier as private, we will see it soon. So if you decide to create a private methods, you tell the other classes that none of you can see my method, including a child. So if the child cannot see this methods, how can this class overridden this method, okay? So the main condition is that the method can be seen from the child side. يعني أنا لو كان عندي class عفوا لو كان عندي method معرفة داخل السوبر كلاس البارنت ولكنها معرفة كبرايفت بما معناه إن no one can access it, no one can see it. If I call this method XYZ and at some point during a child, داخل الchild, I decide okay, I will overridden. I'll write the same class but with a different implementation. I can't do this because that class is private and I can't see it. This is the primary condition to overridden a methods from the child. The private methods cannot be overridden. This is why I said, because it's not accessible outside its own class. If a method is defined in a subclass, is private, and its superclass, the two methods are completely unrelated. What does that mean? If you're creating a method called XYZ inside the parent, private XYZ method, and then you created another method inside the child XYZ, they are not related. They are completely unrelated because the child cannot see in the first point the one on the parent, okay? Now what's about, we talked about the private. So what about the static method? Can we inherit the static method? So if you have a static method, it can be inherited. However, a static method cannot be overridden. Okay? في الحالة الأولى, when you're having a private method that the child cannot see it, it's not going to be inherited or overridden. But in this case, when you're having a static, what does static mean? Mean you cannot change it. Overridden in one of the type that you change it. So you cannot overridden the methods. If the static method is defined in a superclass, is redefined in a superclass and a subclass, the method defined in a superclass is hidden. So if you decide to do this, and you define another method with the same name, you overridden it, the one on the superclass is going to be hidden. There is another concept called overloading. What do you mean about overloading? Overriding, you see an example. We saw an example of overriding. Overriding, you have a method called, for example, public, and then the name. So the whole sentence, the whole header of the method is going to be similar. So if it's public, it's going to be public, name XYZ. Is going to be XYZ. If it has 0 argument, the overriding method is going to be 0 argument. If it has 1 argument with integer, it's going to be 1 argument with an integer, and so on. Yes, so it's going to have the same signature. What do you mean about signature? This is, I'm talking about overriding now. Still not talking about overloading. So overriding, it is going to have the same return. So if it's going to return integer on a parent, it's going to return integer on child. If it's the method name XYZ on a parent, it's going to be XYZ on a child. If it's get 1 argument from type integer, is gonna to get 1 argument from type integer on a child as well. This is an overriding. It's like copy-paste signature, exactly same things, exactly same type of return, same name, same type of argument, same number of arguments. But what if we have the same method name, we having XYZ method, but in the parent we have 0 argument, but on the child we have int I, for example. So it has 1 argument with a type integer. In this time, when we having the same name but different argument or different type of return, is gonna to call overloading. Okay, so overloading is the process of having more than 1 method in the same class or inherited. Sometimes in the same class. You remember, like when we having full constructor, when we create a constructor, most of the class have a constructor with a 0 argument, constructor with a 1 argument, constructor with a 2 arguments, but they all have the same name. Similar idea, not exactly. So a similar idea, inside the same class, you can have the methods with a different argument, different signatures, or inherited from superclass, as what we saw at toString. But they have to have the same name, but a different method signature. So you remember a header, it has a return, it has a name, and it has an argument. So we decide, for example, let's return integer on this is the parent or superclass, and this is a child. In the parent, we return type integer and it has 0 argument. However, in a child, we decide to have 1 argument with integer and, for example, having no return, void. So this is overloading. Okay. Any question about the overloading or overriding? And the other, and again, we already explained it, but let's say it again. The overriding has the same name and the same signature in a super and a sub classes, but with a different implementation. Okay, so both of them is going to have the same name, but a different implementation inside it. Okay, let me make sure, like, you understand what we just said about the overriding or overloading. So this is an example here. So they are both exactly same one, the one on the left and the one on the right, except this part here. So what we are doing, we have a class called test. It has a main method. And then we have another class called B, and it has a method called P, and it has no return, and one argument with a type double. Then we create class A as a child of B, but then we override or overload, I need you to tell me, the methods B. So is this override or overload? So we having same return, same name, same argument, same signature. So what is this? Same return, both of them is void. Both of them have the same name P. Both of them have the same argument. Yes, it's overrides. On the other hand, we see the next example. You already know what is it now. So you see, we having the same return. So this is the parent. So we having B, and we having A. Should I write the arrow in this side or in this side? One. The arrow should be in this side or in this side, 1 or 2? The P is already here. You create the P, Asil. So the P, you create a method called P. So the arrows should go up or down, 1 or 2. Good. So A inherited from B. Okay, I need you to remember this. This is wrong. So A inherited from B. And this is, you already told me, it's overload because it has the same return, void, same name, but the argument here on the parent, which is B, is double, and on a child, which is A, is integer. Okay? Yes, exactly. It's overloads because it has different type of arguments. Whenever you're having different type of arguments, different type of return, it's going to be means that you have different signatures, so it's going to be overload. Good? Okay. So let's do this. Example for overriding. We having class, they called it parent and child, so they make sure you get the concept, the idea. So let's start from the main, from class test. We'll go to the main. First, we create an object called K, and with a type, what's the type of K? It's type object parent. But we're gonna to create it from, we're gonna to invoke the constructor from the child. And I need you to remember this. Later, we create P object from type parent, and then we create to distinguish them, and we create object called C from child. Okay. So now I say C dot methods. So a parent has method, and a child, which is extended from a parent, has a method as well. So this is the first method, and this is the second method. Okay. And I need you to tell me. Let's do it one by one. Okay. So first, I'm here. Which method is going to be invoked? Number 1 or 2? And what's going to be the output? Which method? When I say C dot method, so the C is the object. C dot methods, we invoked in methods. Are we invoked method number 1 on the parent from parent, or methods from 2? What's going to be the output? What's going to be the output? Good. So the output is child 2. So we send 1 here. It is going to be 1. Multiplied by 2 is going to be 2. What about 2? P dot methods, and we send 2. What is going to be the output? Which method is going to be invoked, 1 or 2, and what's the output? We move to the second one, guys. So we move to here. The second object, P. Okay, so we invoke the first methods. Okay, and what's the output? It's parent. No, Muhammad, it's not child 4. We're gonna to invoke UCP, so from type parent. Okay, Muhammad. That means we're gonna to invoke the first method here. And when we send 2, it is gonna to print 2. Yes, so it's gonna to be parent 2. Good. And the last one, when we invoke the method for object K, and we send the 3. This is a little bit, it's going to confuse you guys. So it is type parent, but we create an object from child. We call it constructor from child. So we send the 3. What are we going to get? Child 6. Why we call the methods, why we invoke the methods on 2? Because we call the constructor from the child, not from the parent. Okay? So we send the 3 here, is going to be 3 multiplied by 2 is going to be 6. Good? Now we will talk about المodifier. إيش نعني بالmodifier? What do you mean about it? It's the word before method. You see, public, method, private, and there is a new type, which is we're gonna see it now, it's protected. Okay? So the protected, when you put it before the class as a modifier, can apply on a data and a method in the class, on a class, okay? The protected data or the protected method in a public class can be accessed by any class in the same package or its subclass, even if a subclass are in a different package. What does that mean? We'll see it in an example soon. The private, when you have a private method, no one can see it except the class. It's a private. When it's public, everyone can see it. The protected can see it in the same package or subclasses. So the package, it has set of classes. We will see an example, okay? Let's go on it. So I need you to remember this. This is going to really help you guys. The visibility is going to be increased. So the private, only the class. And none, when you don't define it, the default, it is going to be less, more visibility. The protected is more visibility, and then the public more. And this table will show it, show an accessibility summary of this modifiers. Okay, so the public. So here, let's try to just emphasize what do we mean on that table here. So same class, that means inside the class. In the same package, so you can have a package and it has a class 1, 2, 3, 4. When it's inside the same package, so you have class A and class B, they're in the same package. So this is what we mean. The subclass, the one that we just explained. So if you have a class A and then class B inherits class A. So this is a subclass. So B here is a subclass. Different package, that means class A is here, but class B inside different package. Okay, so let's see. If it's public, if you put public methods, all classes can see it. The same class, the classes on the same package, the subclasses, packages on classes on a different package, all of them can see it. The protected is less visibility. You remember? Like this, we increase the visibility. So this is the more public one that all see it. The private is less. So the protected, it can see by the same class. It can see by all the classes in the same package. It can see by subclasses, but it can't be seen from a different package. It default, if you don't define a modifier, it's going to be default. It can seen by the same class and all classes in the same package, but not the subclass or classes from a different package. The most restricted one is the private. It only can be seen from the same class. Okay. This is a great example. Let's try to focus on part by part on it. Okay. So let's focus here. First, I need you to just remember how the full picture looks like. So we having package P1, which is include class C1, class C2, and class C3. And then we having another package P2 include class C4 and class C5. Okay? And then C4 and C3 are inherit the C1. Okay, so let's see the accessibility from each of those. Okay, so this is the main class, the C1. We create different data and methods with a different modifier. So we have the public, the protected, a default. So here we didn't say anything. We didn't define if it's a private or not. Z is using the default modifier. And then we have the private U and we have the protected M as a method. If the class C2 is a class, it's not a subclass, but it's a class from the same package. That means it can access the public or protected with default variables. But the only thing that this cannot be accessed is the private one. And actually, none of the classes get to be able to access the private. Okay, so it can access the public if it's a class C2 is a class from the same package. It can access the public, the protected, and a default. What if can you hear me now? Okay, so it's fine. What if we have a class which is C3, it's a child from C1. It can access the public data, it can access the protected data, it can access the default data, which is Z, but it cannot access the private. But this is not because C3 is a subclass. See here, guys, I have C4. C4 and C3 are subclass of C1, right? C4 and C3, both of them can access the X, which is the public, and they can access the Y, which is the protected. But the C3 can access Z, but the C4 cannot access the Z, which is the default. Why? Why C4 cannot access Z while C3 can access Z? Both of them are subclass, but C3 in the same package. C4 is from another package. That's why it cannot access a default value, which is a Z. Okay? And the last one, C5, which is not a superclass, sorry, which is not a subclass, and it's from different package. Okay? So we are talking now about C5. So it's from different package, and it's not. You don't see any lines to go there. So it's not a subclass, and it's from different package. That means the only things can be accessed to S1 is the public variables and methods. Any other things, private, default, or protected, all of them cannot be accessed by C5. Okay? Any question about it? This is an important one. Try to go back to it and do it by yourself, okay? Okay, so since we just finished talking about the modifier, we understand that some modifier is stronger than the others. So the public, the visibility of the public is the most visible way to get the methods is using public, and private the lowest one. We talked about using the override methods. Okay, a subclass may override a protected method that's it's already in superclass and change its visibility to public. So if you're having a method on a superclass with a protected modifier, you can override that method and have it public. Why? Because the protected is less visibility than the public. Okay? One more time. I needed to remember we talked about this one, right? So, if you're having a superclass A and you're having a class subclass B, you have a method X, Y, Z in A, and then you would like to override it on a B. If an A is a public, sorry, if an A is protected, You can write الB as a public. That's fine. Why? Because the public has more visibility than the protected. But let's assume you have a parent, XYZ have public. So public XYZ. Can you do protected XYZ? Can we do this? Yes or no? And why? Those who saying no. So we said if a parent has protected, then we can increase the visibility to have a child have public. But what about the opposite? If I have a parent has a public, and I said, oh no, I would like to have it less visibility, weak, it's more weak than a parent. Can we do this? Exactly. No, we cannot do it. Why? Because it's decrease the visibility, and this is not allowed. So you have to have always a parent always have at least one level. This is, let's say this is level 1, 2, 3, 4. So a parent has to have to be at least on one level more than an overridden method on a child. So if this is in level 4, this has to be at least on 4. If this is in level 3, protected, it can go higher, but it cannot go lower. If it's default, you can go with a 3 or 4, but you cannot go lower. Okay? So this is what is this slide mean? So you cannot weaken a method to make it less visible. Okay? There is a modifier called final. What do you mean about final? That you cannot change it anymore. Okay? So if you have a final class, it cannot be extended. It cannot be inherited. And if you have it as a constant, if you have it on a variable, it's going to be constant, like when we have it on a byte. The final method cannot be overridden by the subclass because it's final. That's mean you cannot change it. The object class, we already said it's the mother, it's the parent of all other classes, okay? And for this reason, even if when you create any class, even if you don't say that it's extended from an object, it is, okay? So it's going to by default or included on the implementation, it's going to be inherited the features and the methods from an object class. This is what I explained to you during when we compiled the example. You remember when I eliminate toString from a simple geometrics, and then we get the result at and then number? This is what you mean. The object class has toString methods. That's why even if you don't implement your own toString, that means the object is going to use the one implemented inside the object class. So inside the object class, we already have toString, but this is going to return us a representation of that object, which is at and then a number. Okay, I wish you remember this from meeting 2, when we talk about string. when we compare string. And meeting 2, slide 18. I wish you back to this one later. We distinguish between when you're using equals and equal. Okay? So equals gonna to compare the contents of the objects. However, equal gonna to compare if the objects are referred to the same object. But you can change the implementation. You can override the implementation of the method equals. The method equals, it's a built-in method on Java. So, for example, here we built on equals. So we send object, type object called obj, and we compare it with a this, whichever is this, the class, if it's equal to the object that we just sent. So in this example, we send the O. If the O is instance of circle, instance of is the methods on Java, it's gonna to be okay. It's gonna to be return true if the O from type circle. Okay. And it's gonna to return false if it's not from that type. So if it's a true, please return a radius for me. So this is exactly what we told, what we examined in a meeting 2 on slide 18. I need you to back to the exercise. So when we say equal, we ask if it's have the same references or not, if you're having two objects. When using an equal methods, is intent to test whether object have the same content or not. So that's why equal is more stronger. It's not always test content. It's also examine if it's have its reference to same object. Okay. An instance of, I just saw it in I already explained it in the previous example, is gonna to examine if this object is an instance of this class. This is going to be useful if you have a long code, or if you are using a code from with other person or so, and they're creating an object, you're not sure what's the type of the object. So you can test it using the object name and then make sure if it's from, it's an instance of this class or not. I need you to try this example. Change the override of the object to string for circle, rectangle. You already have the code on the slide. As I told you, you can just click on the green buttons and you will have the code there. Okay. The last concept we're going to talk about is polymorphism. What do you mean about this? It's used when you have a word or a symbol, but it's going to be used for a different things in a different context. And we already get an example. You remember an override or an overload? You have the same method's name, but it's going to have different implementation and so on. So this is an example of polymorphism. The most common referred to when a parent class refers to a child. When you're having different another constructor from a child, as we saw in the example, you create from type of parent and then you call constructor from a child. Another method is having a method with the same name but a different class, with the relationships or without. This is what we saw in the overloading and overwriting. Okay, so polymorphisms mean that the variable of supertype can refer to subtype objects. So now we talk about the supertype and a subtype. It's like when you're having a superclass and a subclass. But now we are talking about the object. We are not talking about the class. So we're having a superclass and a subclass. But whenever you're creating an object, an instance from the class is going to be called supertype and subtypes. A class defined as a type defined by superclass called subtype, with type defined by superclass is going to be called supertype. So inside the main method, you create an object, you create an instance, right? Those instances or those objects called supertype and subtypes, okay? So when you create an object from circle, it is going to be subtype from a geometric object. With geometric object is going to be supertype from circle. So we see here, in this example, what I need you to focus on is this part on the top. So we're having a method named M. And we're gonna to create an object from a graduated student. Where is the graduated student? Is here. Graduated student class is extended from what? From student. Where is the student? Here is the student. A student is extend, so this is extend from this. A student extend from a person. Okay? Where is the person? This is the person. A person extend from an object. The object is the main class on Java. So we don't have it here because it's already built in. So you see how it's one graduated student is a child from student is a child from person is a child from object. Okay? So in the first part, we send the graduated student, which is this one, and then we send the student, the graduated student, when we call this method M, and we send what's the type of X is object. Why it's object? Because a person is extended from an object, and a student extended from a person, and the graduated student expand from a person. An object is a class. Okay, I see. Object is a class. It's called object, and it's already a general term for any type of object. Okay. What is it exactly? It's a general. It's a general time. It's a general term. When you remember when we creating class called students, for example, you, Asil, is an object of this class. Another student is an object. What's an object mean? You have the same probabilities, but you have your own data. Okay? So this is what object can mean. Let's back to our topic. So here, if we call an M, what are we going to get an output? So the method M take parameters of object type. So that means you can invoke it with any object. So the person is object, student is object, the graduate student is object. Okay. An object of a subtype. إيش يعني subtypes? For example, a person is a subtypes from an object. A student is going to be subtype from a person. The graduated students, the object here, I mean, it is going to be subtype from students. So subtype can use whenever is a supertype value is required. So this is the polymorphism. So let's see. First, in the graduated students, we go to the graduated students, LM. So it's going to print to string. Which to string? Because it doesn't have its own method to string. So it's going to back to its parent, which is a student. Does it have to string method? Yes. So it's going to print whatever it has on it. So it's going to print students. Later, in the next one, in a student, it's going to come to student. Does it on the M, because it has X to string. Does it have to string methods? Yes. So it's going to print to student. Later, we will have M for a new person. M going to say to person, to string. We're going to back to person class. Does it have to string? Yes. So we're going to return person. And the last one, an object, it is going to go to the string object. And we already said that to string object, what it does is going to return a name of the object and a present number. Okay? So this is what I just said. So if you have class C1 inherited from C2, C2 inherited from C3, and so on and so forth, until the object is the root, is the main one, is the main class. So if I say I create an object O, okay, if I have an instance O object from this type, and I said dot to string, first I checked, do I have a method to string in C1? If yes, I'm going to use it. If it's no, I'm going to go one step back and check if the first parent does it have to string method. If yes, I'm going to use it. If it's no, I'll keep searching for the next one and next one until I get it. So this is what GVM doing, is searching for the implementation for the method P. So if you say object O dot P, you are searching for method P. First, it's gonna to check for the same class. If it's there, it's fine. If it's not, it's keep searching for upcoming ones. المethod matching versus binding. Matching, as we said, it has the signature. Okay. Compiler find the match methods accessing to parameter type a number of parameters. So how will compiler, I told you in the previous example, is going to try to search for that methods. How is going to search for it? Is going to make sure it has the same signature. So if we are searching for toString, it is going to search for toString with a same return and a same argument, same signature. And because methods can be implemented in several subclasses, as we just saw before, it can be implemented in the parent or parental parent or so on. Yes, you can, Iman. Okay, so the Java virtual machine, GVM, dynamically binds So what does that mean? It's going to search for the implementation. It's connected, that implementation have the same one. Okay. So this is what his generic programming means. So if we're creating an object, all of them, the graduated students, the students, the personal object, they all are objects. So this is object argument, and it's known as generic programming. So an object here, this is the key of this page. So an object here, it can be used for any of those. Okay? Casting an object, if you remember, we're doing casting for an integer, a string, and so on. So what if you would like to do a casting for between an object? What you can do is casting between from a sub to a super. If you're having, for example, an object O, and then you're creating a new student. So this is a super and this is a sub. Okay, so if the student is inherited from an object. So how we can do this? The statement object new student now as implicitly casting. You remember one of the example when we're doing a parent, we do parent P equal to a new child, if you remember in the previous example. So this is implicit casting. You're creating from a super, but actually you call, we already almost done. One more slide, that's it. Okay, so this is implicit casting, good? And then why we need casting? Because suppose you want to assign the object refer O to a variable of students. So you're creating object P from type student, and you would like to assign another object to it. This is compiler wrong because the compiler cannot understand that it's O from type of student. What you have to do, you have to say student P equal to, you have to explicitly casting it. The only one that you can do implicate casting if you're having the superclass here. So if it's from superclass to child, you can do implicate. مضمن. لكن if it's from less than or from child class, you have to do it explicitly. Okay? So here you need to remember, for example, if you're having a fruit, if you're having an apple, X, yes, you can, Lujan. So if you're having an apple X, and then you're having the fruit is a super class. So you have to have an apple before it. The easy way to remember it, you can always remember that an apple and an orange, for example, are fruits. They are always a fruit. The instance of apple have to be a variable for fruits. However, the fruits not necessary to be an apple. That's why if you get to do it, you have doing explicitly casting to make sure you mean an apple. Okay, so that's what we mean. If it's you're gonna to go from a super class to a child class, you can use an explicit casting. Sorry, implicate casting. However, when you do the opposite, you have to do an explicit casting. Okay? And this is the end of the meeting, and sorry to keeping you guys. Okay? Any question? Yes, if you have a class, you can leave, guys.